Hey everyone, let's see this question 13 in which we have given a matrix. Okay, we have given a matrix M and we have asked that which of the following are or is true about its eigenvalues. Okay, so the very basic thing or the very first thing to solve this question is we can calculate the eigenvalues because it is a simple 2 cross 2 matrix. So it won't take long time to calculate the eigenvalues. So let's see this method first, and after that we'll see that how we can also do it without calculating the exact eigenvalues by just logical deduction or region elimination. Okay, so how to find the eigenvalues? It is simply determinant of m minus this lambda I, and we'll equate it to 0. M is simply our matrix, so we have to find the determinant of this matrix. 2 minus lambda, 3 minus 1, and 1 minus lambda. Okay, this I is here is identity matrix. I hope that is clear. And then we'll find the determinants, that will be 2 minus lambda, 1 minus lambda, minus 1 into 3, and let's equate it to 0. Fine. Solve it further, it will be 2 minus lambda, 1 minus lambda plus 3 equal to 0. We can write it as 2 minus 3 lambda plus lambda square plus 3 equal to 0, or lambda square minus 3 lambda plus 5 equal to 0. Now we need to solve for lambda. Okay, so as you can see, we have to solve it with the help of quadratic equation. We can't just factor it. Okay, so we'll put the values in the quadratic equation, that is minus b plus minus under root b square minus 4ac upon 2a. So I won't write the formula, I'll directly put in the values. So minus b plus minus under root b square, that will be 9, minus 4ac. So 4 into 5 into 1 upon 2a, that will be just 2. That comes out as 3 plus minus root minus 11 divided by 2, and we can write it like 3 plus minus I root 11 upon 2. So from here you can see that the second option is correct, that the eigenvalues of m are complex conjugate pairs, because you can write it as 3 plus I root 11 by 2 and 3 minus root 11 by 2. So this will be the right answer. But let's say you don't want to do all these calculations and you don't need to figure the exact eigenvalues. So how you can solve it without doing all this? Okay, so we'll use some properties. So first property will be that sum of eigenvalues are equal to the trace of the matrix. Okay, what is the trace? Trace is the sum of the principal diagonal elements. Fine. So we know that sum of our eigenvalues is equal to trace, and what is the trace? That is 2 plus 1 is equal to 3, and the product of our eigenvalues is equal to the determinant of this particular matrix. Fine. So our product of eigenvalues will be the determinant of this particular matrix, that will be 2 cross 1 minus 3 cross minus 1, which equate to 5. Okay, so we now know if a and b are our eigenvalues, then a plus b is equal to 3 and a into b is equal to 5. Okay, now we can do some reasoning with our options and see that which is correct and which is not. So let's start with option D. It is saying one eigenvalue of m is non-negative and real, and another eigenvalue of m is negative and real. So if one eigenvalue is negative, then the product of both the eigenvalues will be negative. But we can see here that product of both the eigenvalues are 5, is 5. So option D we can eliminate because it is not possible. Let's see option C. One eigenvalue of m is positive and real, and another eigenvalue of m is 0. So again the same, that if one of the eigenvalue is 0, the product should have been 0, but product is 5. So again we can eliminate the option C. Let's see the option B. The eigenvalue of m are complex conjugate pairs. Now we can't say anything about it because the sum of complex conjugate pairs could be 3 and the multiplication can also be 5. Now let's see option A. Now option A is saying the eigenvalues of m are non-negative and real. So both eigenvalues should be 0 or greater than 0. Now if you see the product and the sum, you'll see some ambiguity here, that let's say you have the product as sorry, the sum is 3. Now it could be either 3 plus 0 or 2 plus 1 or 1 plus 2 or 0 plus 3, but you got the point. So anything or anything in between. So if you reduce 2, the 1 should go up and vice versa. Now if you see the product here, it won't go till 5, right? 2 and 1 will be just 2, the product. And if you do like 2.99 plus 0.001, that will again, it won't get till 5. So one value need to be less than 5 to get this product. It is not possible to have both the values non-negative and have the sum 3 and have the product 5. So this option will be also be disqualified, and the correct answer or the only option that will remain will be option B, and that will be our right on. Okay, so you can try both ways. You can do this reasoning or you can do the calculation and find the actual eigenvalues. So see you in the next question. Thank you.